Hai, Assalamualaikum. I am 018910 NJ Cadet Muhammad Irfan bin Muhammad Jamil from DME43B. Since I have been assigned a SolidWorks project from my lecturer Sir Hidzan, I have choose a project title, Root Blower Pump. So I make this video to explain furthermore about how I did all the parts, also how the drawing will look, how I assemble all the parts to become a root blower pump, and as an extra, I will show how the motion study and how the exploded view will look. So here is my explanation.
So first of all, I need to do a part is the housing. Okay, so I will choose this front plane and then normal to it. So I need to change the unit into metric first. So I will sketch a straight slot here. And then make an adjustment for the measurement by using the smart dimension. So for the radius is 96 millimeters. And then the distance between these two centers is 89.69 millimeters. Okay, done. So by using this sketch, I will choose a features extruded boss. So I will set the thickness here is 10 millimeter. Okay, done. So normal to the front plane, then save it first. Next I will do a new sketching, but then I will use this first sketching and then convert all the entities. And then at the sketch 2, I will sketch 4 circles. Start with the 2 bigger circles here and also here. And then another 2 small circles also here. And then do an alteration. So for the bigger circle, diameter is 139.5. So 139.5. And then for the small one is 20 millimeter. And then this big circle 139.5. Okay, done. So let's save it first. So next, by using the sketch tool, I will use the features extrude both. So for the selected contours, I will choose the outer here, and then the distance will be 150 millimeters. 150, and then done. And then by using this same sketch, I will use another features, that is extrude cut. So as the contours, I will choose this curl and also this curl, and then I will select through all. To the opposite direction. So these two small circles will be like a holes. And then done. Let's take a look. Isometric view and then save it. Next, I will go normal to back the front plane. So we'll choose this one and then make a new sketch. So this is named as a sketch 3. Same, sketch another straight line. Make an adjustment. Now the radius is slightly bigger. That is 111. Equal 1 millimeters. Okay. So next, I will select this and then select loop and then select convert entities for our new sketch 3. So I will start to sketch center line. Okay. Then another center line. Okay. And then a bold straight line randomly. As example. So it should be 4 lines actually. This is 1, 2, 3 and 4. 2 lines at the left of the housing. So before I start the mirror features, I need to ensure this line and also this line in horizontal relation. Make sure it is in well aligned condition. Okay, then I will do an alteration for the distance here. Half of 100, that is 50 millimeters. 50 millimeters. Okay, when it's done, so I will choose this line and the center line, and then I will choose mirror entities. So for the left part, I will choose this line, these 2 lines here with these center lines, and then mirror the entities. So everything is clear now. So we have 1, 2, 3 and 4 lines. for now. So next, I need to make a closed geometry here. So at the upper of the housing, and another one is here. Done. Okay. Since there are excess of the lines, I will start to trim the entities. And then the option is under the power trim. So I'll move the cursor freely like this. Like this. Okay. Like this. Like this. And like this. So we only have 1, 2, 3, and 4 parts. Okay. So by using the sketching, I will start to extrude. So for the selector contours, I only will choose this contour, and this contour. Since the direction is here, so I will change the direction first to the opposite direction, and then I will select through all. Let's take a look. So everything is look nice. So I will set this part housing into isometry first, and then save it as usual. Next, the things I need to do is our bolt hole. There are 50 numbers of the bolt holes with a depth of 30 millimeters. Okay, so to be easy, the new sketching, I will normal to back for the front plane here. So as a reference, I will choose this sketch tool to be shown. Okay, and then I will start a sketch a circle. Okay, and then do an alteration. The diameter is 10 millimeters now, so I will type 10. Okay, and then the distance between this center and this center is 82.875 millimeters. 82.875 millimeters. Okay. So I think we can hide back the sketch number 2, and then I will start to do features of extrude cut. So we can see start to cut here, but then I will increase the number of depth until 30 millimeters. Okay. Since the number of holes I need to do is 15, so I will use a features that is a curve driven pattern. Okay, so as a reference, I will choose the first sketching. Okay, and then make sure it under offset curve, and then the number of the holes is 15, equal spacing, and then we can proceed. So this is the holes for our bolts. So as usual, I will set this part into isometric first and then save it. So next is I need to do a inlet at the top of my video outlet. Okay, so I will choose this upper plane here and then right click to do a new sketching. I need to sketch a 3 circle actually. So to easy my job, I will do a center line sketching. So I will choose this edge and this edge. So now I have a guide for the center. Then I will proceed with the circle. 1 and 2 circle. As usual, I will make the alteration. So for the outer circle, diameters is 120 millimeters, and for the small circle or the inner circle is 80 millimeters for the diameter. Okay, done. So by using this sketching, I will proceed with a features that is extrude boss. Okay, so I will increase the number of height into 30 millimeters, and then by using the same sketching here, I will proceed to do a features that is extrude cut. Okay, sketching extrude cut. Okay, but then that is not my target to be cut. Actually, I need to cut the inner contour. So I will choose this contour and this contour, the small circle here. Okay, so take a look. It's still not cut until here. So I will change the direction is up to next. So now the holes, it become a holes that I desire. Okay, and then I can proceed. As usual, I will set this part into isometric first. So next, I need to do the third circle, the outer circle. So I will choose this plane, the top plane circle here, and then do a new sketching by using the same center line here. I will do this circle, same do alteration. So now for the outer circle, the diameters will be 160 millimeters. So 160 millimeters. Okay, done. I will choose this and then convert the entities. So it will select this circle and this circle to be extrude next. So by using the sketch 6, select extrude boss, but I will reduce the number of the thickness is only for 10 millimeters. Done. As usual, I will set into isometric view and then save it. So the next thing I need to do is bolt. There are 8 numbers of bolt. So I will choose this top plane and then make a new sketching. And then I will start sketch a circle randomly here. And then do an alteration as usual. Now the diameter is 15 millimeters. 15. and then the distance between this center and also this center is now 52 millimeters. Okay, and then to ensure this small circle is well aligned, so I will sketch a center line from here and here. And then I need to ensure this line now is horizontal. Then by using this latest sketching, I will start to do features, that is extrude cut. So check the direction is correct downwards. I will increase the number until 40 millimeters for the depth. Oh, and then can proceed. Okay, before I forget, I need to make this part is properly closed from here into the housing. So I will re-edit a features, that is boss extrude 4. Okay, so take a look. So now it's only have a one direction. So I will add another direction downwards, and then I will choose up to next. So now this part is properly closed between the top into the housing. And then we can proceed. Okay. So since the numbers of bolt is 8, so I will choose features that is circle pattern. And then for our reference is this part. And then the features that I need to select is the latest features. Cut extrude 4. Okay. And then we increase the number into 8. Check the degrees, 360 equal spacing. So then now I will proceed. Okay, let's count. 1, 2, 3, 4, 5, 6, 7, 8. So it's correct. And then I will sit back this part into isometric view and then save it first. So next I will proceed to do the left and the right part of the housing. Okay. To use a mirror features to make my work easy, I just do a part here and then will mirror at the other part. I need to do a new center plane. Okay. So let's take a look. This right plane is not in the center. So I will select a new plane. So as the reference, I will choose this face. And the second reference is this face. So now take a look. This plane is at the center. Done. Okay. And then by referring from this plane, this new plane, I will add another plane. And then make sure the distance for the new plane is 200 millimeters. millimeters. And then done. So I will normal to the new plane here to do a sketching. I will increase the size of this plane. Okay. And then I need to sketch a 3 circle. But then for make sure the job will be easy, I will do a sketching of a center line first. Okay, now I get a center line, then I can proceed to sketch 3 circles. First circle, second circle, and then third circle. Okay, and then do alteration as usual by using the smart dimension. So for the inner is, for the smallest one is 60 millimeters. Okay, and then for the bigger, the diameter is 90 millimeters. And then last but not least, the biggest one, or the outer, is 120 millimeters for the diameter. Okay, done. Can proceed. So by using this sketching, we'll start to do features, that is extrude both. So I will choose this inner contour first to be extrude. Since the direction is not into this wall of the housing, so I will change the direction. And then up to next. So now it properly close into the housing wall. Okay. Then proceed. And then I will repeat by the same sketching. I will start the extrude both, but then with the outer contour. So here and here. But then I need to do the backward, so I change the direction, and then the thickness is only, the outer flange is only 10 millimeters. Okay. And last but not least, by using the same sketching, I will start extrude cut. By selecting this contour and also this contour. So I will choose up to next. So the holes will be until the inner of the housing. Okay. Now it cut already. Let's take a look. Okay, and then I can proceed. As usual, set it back to the isometric view and then save it. Next, the thing I will do is the bolt holes for these faces. For this face, so I will do a sketching, zoom it, and then I will sketch a circle here, and then do alteration for the measurement. Now the diameter is 10 millimeters. Okay, and then the distance between this center and also the small circle center is 37.5 millimeters. Okay, then can proceed. So now by using the latest sketching, I will start features that is extrude cut. Okay, let's take a look. The direction is correct, everything is correct, and then we increase the number of depth until 30 millimeters. Proceed. So since the number of bolts is 8, so I will use a features that is circular pattern. So for the reference, I will choose this outer, and then the features is the latest cut extrude 6. Okay, let's take a look. There are 8 numbers, correct? 360 degree equal spacing, and then we can proceed. Put it back into isometric view and then save it first. Okay, so next is I want to mirror this new part into the left part of the housing. Okay, so let me hide this plane first. Okay, and then I will choose mirror features here. So the reference plane is this plane, and then the features that I need to choose is the latest features. So I will choose this, this, and this, and this, and also these features. So let's take a look. Is it all selected? Yeah, now it's all selected, and then can proceed. So let's take a look. Hold the number of bolts 1, 2, 3, 4, 5, 6, 7, 8. So everything is correct now. So we'll see it back this housing into isometric view and then save it. So last but not least, the thing I need to do for the housing part is heatsink. So basically the heatsink we locate at the outer wall of the housing, which are here, and also the bottom wall. Okay, so I will choose this front plane and then make a new sketching. And then I will sketch a straight slot here. So here. And then do alteration for the measurement. So for the center to the center is 89.69 millimeters. And then for the radius here, since the thickness of the heatsink is 8 millimeters, so the radius will become 104 millimeters. Now we can proceed. Okay. So I will choose this axis to convert the entities for new sketching. Also same here, I'll convert the entities, and also the upper axis, convert the entities. Same here, convert the entities. Same here, also convert the entities for the new sketching. And last but not least is this axis, convert entities. So by using this latest sketching, I will use a features that is extrude boss. But then for the contours, I will select this, and at the bottom. Okay. So now the direction is to the front. So I will reverse the direction facing to the housing. And then check for the thickness is 10 millimeters. Then can proceed. Let's take a look first. Yeah. Okay. So for the number of the housing is basically is 8 numbers heatsink for the housing. Okay, so I will choose a linear pattern features. So for the heatsink reference, I will choose this axis. And then the features that I will choose is these features. Okay. Since the thickness is 10 millimeters and we need 10 millimeters of gap, so I will increase the distance into 20. Let's take a look. Now the heatsink is fulfill all the wall of the housing. Okay, and then I can proceed. Let's take a look first. Heatsink at the bottom, completely done. So now I will put back into the isometric view and then save it. So this is how the housing will look. And then I will proceed to do a painting here. So for this part, I will choose this blue color. So I will paint all the parts here. Is in blue colors. Yeah. So take a look. Oh, there are one left. Okay. As usual, put it back into isometric view and then save it. So now this is my drawing for the housing. I present this drawing into the third angle projection. So this is the plan view, the front view, and also the end view. All important measurement is shown here. So secondly, I will start to do a cover for the housing. As usual, I will choose the front plane and then normal to. Start to do a sketching, straight slot sketching. Okay, change the unit into metric first. Okay, and then I will do the re-sketch. Okay. So I will do the alteration here. For the distance for both center is 89.69 millimeters. And then the radius for the circle is 96 millimeters. Millimeters. Okay. And then I will choose the sketch to do a features extrude boss. Okay, so the thickness is 20 millimeter. Normal to and save it first. So next I need to do a 4 circle. 2 circle is the inner for maybe for the impeller, and then I need to do another 2 small circle. Basically is used for the shaft slot. Okay, so let's start sketching. Circle sketch. I will choose this plane. Okay, and then another one. As usual, do alteration by using the smart dimension. Okay, for the diameter for this both circle is 139.5. 139.5. Same here. 139.5. Okay. And then start sketch. Another 2 circle here. 2 small circle. Do an alteration. So for the shaft hole, basically the diameter is 20 millimeter. Okay. Then I need to maintain the distance between these two centers is 89.69. Okay, settle. And then save. To ensure this circle that I did is well aligned, so I will make a relation between these two centers, and I will add a relation horizontal. Okay, this thing is to double confirm that the circle is well aligned. And then I will use a features extrude cut. So at first I will choose the big circle here for the impeller as the contour. Here, the middle, and also at the right. So the thickness to be cut is only 10 millimeter. So this is how it will look. I think we can proceed. And then for the two holes, I will choose so by using the same sketching, I will cut the two holes here. So I will choose these small circles as the contours. Okay. Through all. Okay, so this is how it looks. It will be a holes for the cover. So I will normal to back and save it. Since this cover need to have 15 numbers of bolt holes with a 10 millimeter diameters, so I will start sketching here to do a circle, and then same, do an alteration. The diameter now is 10 millimeters. And then I need to ensure the distance between this side into the center. Is 82.875 millimeters. Then settle. Then by using this sketch, I will start a features extrude cut. So I will choose through all. Okay. So normal to first, and then save. So next, since the number of hole is 15, so I will choose a features curve driven pattern. So for the direction one, I will choose the first sketching. And then for the features and face, I will choose the letters that have been extruded. Okay, so the number here is 15, equal spacing. And then take a look first. Okay. So now we can proceed. As usual, I will start to normal to back and then save. Put into isometric view since everything is complete, and then save the cover project. So yeah, for the painting, I will choose it as a blue color. Okay, done. Ensure all blue colored, and then as usual, put in isometric view and then save it. So now this is drawing for my cover under third angle projection. So here is the pan view, the front view of the cover, and last but not least is the end elevation. So for the third part, I will start to do an impeller. So I will choose the front plane and then normal tool. And then I will start to sketch the center circle, the small circle, and then another one bigger circle. I will change the unit into metric first, and then I will do the resketching to change the measurement for both circles. For the small circle, diameter is 20 millimeters, and another one is 45 millimeters. The distance between these two centers is 47 millimeters. And then save. To ensure this two circle is well aligned, I will make a relation between these two centers, which is horizontal. And then save. So next, since the impeller has 3 blades, can refer this big circle, so I need to do another 2 circle by using a features that is circular pattern. Okay, I will choose this center as my reference. And then the entities I will choose the circle. Okay. So this is 1, 2, 3 numbers. So I will reduce the numbers into 3. The distance is still remain 47 between the center with the point circle. Numbers is 3 and 360 degree. So it's done. To proceed. Since my sketching is still underdefined, so I will change the status here to be fully defined. So I will use these features, fully defined sketch, select all the entities in the sketch, start to calculate, and then now the status become fully defined. So we can proceed, and then save. Next, I will sketch a 3-point arc. Okay, to this 3-point. So I will make a relation to ensure this new arc and with these two circle is relate as a tangent. So I will choose this arc and this circle as a tangent. Okay, same to the another circle. So the relation now is a tangent. So do an adjustment for the radius. So the new radius will be is 22.5 millimeters. And then you can proceed. Same like the others, the numbers of the arc must be 3. So I will choose a circular pattern again. So as the reference parameters here is the center point. And then the entities that I will choose is the arc. Okay. So reduce the number into 3. And then look, is it mesh or not? Okay, now it's mesh. And then we can proceed. And then saved. So since this sketching is still underdefined, I will repeat the same step to make the status fully defined. So I will choose all the entities, calculate, and now it will become a fully defined. So next, I will use a features that is extruded bows. So the contour I will select is here, here, and here. Okay, so the thickness will be 150. 150 the distance. Okay, so proceed. Let's take a look into isometric view first, and then save project. For the impeller detail, I will paint it as a yellow color. So next, since the key slot is not due yet, so I will choose this plane and then sketch. Let's zoom into the center circle here, and then I will choose a sector rectangle. Then a smart dimension. Since the measurement for the key slot is 4 times 4. For here. And then the other side also 4 millimeters. Okay, done. So from this sketch, I will use a features that is extrude cut. And I will choose the duration is through all. So let's take a look. Okay, done. So since the number of key slot is 5, so I will choose a features that is circular pattern. So my reference is this circle, and then the features I will choose is the cut extrude. Okay, check. Yes, correct. The number is 5, 360 degrees. And take a look in. Then proceed. So this is my impeller. As usual, render it in isometric view and then save it. Done for my impeller. So next, this is how my impeller drawing looks based on third angle projection view. So last but not least, I need to do a shaft. Okay, so I will choose the front plane and normal to. And then I need to sketch a circle here. Oh yeah, before I forget, I need to change the unit first into metric. And then I will re-edit the sketch. Smart dimension into 20 millimeter. Okay, so the diameter is 20. Settle. So next, since the shaft need a key slot, so I will choose a center rectangle. Okay, just put it here. And then do a smart dimension. So the key slot size is 4 times 4. Mm. Then okay. So done. So from the sketch, I will use features extruded boss. So I will choose this contour and also this contour to be extruded first. So the length I need to 215. Settle. So I will use the same sketching from the first sketching to do a extrude. But this time is for the key slot or the remain center rectangle. So I will choose this. So the length is 150. But then there is an offset because the key slot is at the center. The distance is 40 millimeter. From here. Okay. So let's look in isometric view first. Save. So next, I need to make sure the key slot, we have 5 numbers of key slot. So I will choose a feature circular pattern. So for the direction, I will choose this circular pattern. And the features is the boss extrude 2. That means the key slot that have been set for the offset and also the length 150. So here is the number is 5, 360 degrees, equal spacing. So let's take a look. Yeah. So let's proceed. So I settle for part shaft. Okay, as usual, do a isometric view and then save the project. So now this is the drawing for the shaft under third angle projection view. Since I have settled all the parts of the root blower pump, so I will choose the main part to be located at first. So I will choose the housing. Okay, so I will try to match between the coordinate system and the origin of the root blower pump properly. Okay, done. So I will hide both back, and then I will start to proceed to insert the other components, the cover, the impeller, and also the shaft. Okay, so just move it randomly and then done. So at the first, I will try to match between the shaft hole and the shaft. So the first thing I will do, I will choose the shaft hole and the circular face here, and then mate it under concentric. So the next step is I will choose the back face of the shaft and the back face of the housing under distance. So I will change the unit into metric first, and then the numbers of the distance should be 30 millimeters. Bismillah. Then take a look here. Okay, so there are no more maths to do, but then I will repeat the same step and the same method to the second shaft. So instead of using is a component manually here, I just pressing my control key and then drag it freely. Okay, so let's do the same step. I will choose the shaft hole, circular face of the shaft, and then mate it under concentric. Okay, and then I will choose this back face of the shaft and the back face of the housing, same under the distance condition, and change it into 30 millimeters. Then change it manually. So now it's 30 millimeters. And then we can proceed. There are no maths to do. And then to make it easy, I will put all the parts into isometric view. So the next thing I need to do is to matching this impeller into the shaft. So I will select matte. And then I will choose this face of the impeller and the circular face of the shaft under concentric matte. Okay, and then try to align manually because I want to match the key slot here under coincident. So I will choose this face and this face under coincident. And last but not least, I will choose this front face of the impeller and the front face of the key slot, and then under coincident view, coincident type of mat. Okay, so there are no more mats to do. So let's try. This can rotate. Yeah. So finally, it can rotate freely. So I will insert the same component, so I will choose the control key and then I will drag it freely. Okay, so I will repeat the same method. I will choose this face of the impeller and then the circular face of the impeller under concentric. Okay, and then manually align for the key slot. So I will choose this face, the side face of the key slot here, and also this face of the key slot at the impeller under coincident. Okay, and last but not least, the front face of the impeller and the front face of the key slot of the shaft under coincident. So let's try this one. It also can move freely. But then the working of the pump is both impeller need to rotate like a gear. So what I need to do is make a mechanical match. So we choose mat here under mechanical. So I will choose the shaft and also the shaft working like as a gear. So the ratio between this is 20 and 20. 20 to 20. Since there are no more mats, so let's try into the normal 2 of the front plate. So both move synchronously like a gear. So before I go more step, I will put all the things into the isometric view and then save it. So since I have saved this assembly project, so I will try to combine this cover into the housing. So the first thing I need to do is to rotate the cover first. Okay. Since this hole is combined with this hole, so I need to move it into here. So I rotate the component like this. Okay. So next, I will choose this shaft hole here. And the circular face of this hole, of this shaft, to be made as a concentric. So next I will match this shaft hole and also the center shaft hole here to be concentric too. Okay. So let's take a look. All the ball holes are well aligned. Free to move. Okay, so I will choose this face and also this face to be coincident. So to ensure it's in proper location, I will change the display style into hidden lines. So now everything is in proper location. So shadow with edge view, and then put it in isometric view, and then save it first. So last but not least, I will assign bolt to connect this cover and this housing. So I will choose it from design library under toolbox, and symmetric, bolt and screw, hex head, and I will choose the hex flange screw. Okay. Since the size of the hole is M10, so we will change the size into M10, and the length of the thread is 16. Okay, so we'll put into another bolt holes here, here, so here, here, and also here. So now all bolts are fitted. Put it back into isometric view. So this is how my assembly of the root blower pump look, and then save it. And then last but not least, this is how my drawing assembly look by using third angle projection view. This is my plan view, front view, and this is the end view.